Good morning to all of you. I am Dr. D.D. Sawant from Department of Geography, J.A.T Art, Science and Commerce College for Women, Malegaon District, Nashik. Today's topic, which I had selected, that is a water cycle balance. Now, many of the problems which are being creating as the scarcity of water is felt acutely in semi-arid and arid regions, and it becomes necessary to find out other sources of water. So the underground water plays a very important role in such areas. The water that sinks into the ground is known as underground water. Spreading everywhere under the earth's surface, groundwater constitutes a major source of usable water. Where water surface is scarce, groundwater is vital for irrigation. Hence, the proportion of underground water depends on the topography of the region. Secondly, we will see that the characters of rocks. And third one, that is it depends on the climate. So, usually the water cycle is in balance, and the amount of precipitation falling will slowly soak into the ground and eventually reach the rivers. However, if rain falls for a long period of time, or if the ground is already soaked or saturated with water, then the chance of flooding is increased. As far as concerned to the topography, on steep slopes, surface runoff is greater. Hence, the amount of underground water is less. On the other hand, in plain areas, the rate of percolation of water is more than the surface runoff. Hence, more underground water is found. If we'll see the study of characters of the rock, those are the supply of underground water depends on the porosity and permeability of rocks. Porosity denotes the amount of open space in a rock body. Hard and compact rocks like igneous and metamorphic rocks have very few spaces, but water can flow through their joints, fissures, and cracks. On the other hand, sedimentary rocks like sandstones have greater porosity. The permeable rocks allow the downward passage of water, for example, sand, sandstone, limestone, etc., while impermeable rocks do not allow this passage of water, for example, shale, slate, etc. Hence, in an area of permeable rocks, the proportion of underground water is more, while the proportion is less in an area of impermeable rocks. To consider the climate in humid areas, the rate of evaporation is less and water will either flow above the ground surface or will sink into the ground. In a semi-arid and arid regions, the rate of evaporation is greater and thus reserves of underground water are less. As a water table, if you see that all rocks are saturated with water at a certain depth below the surface of the earth. That is, all rock species are completely filled with water. The upper surface of such a saturated area is known as the water table. This water table roughly follows the topography of a region. The water table is highest under mountains and hilltops and lessens in the valleys. It may appear closer to the surface near streams and marshes. So the area below the water table is known as the zone of saturation. The zone between the earth's surface and the water table is called the zone of variation. And the water bearing rock mass is known as an aquifer. As a closed system, the hydrological cycle is a good example of a closed system. The total amount of water is the same, with virtually no water added to or lost from the cycle. So the water just moves from one storage type to another. Water evaporating from the oceans is balanced by water being retained through precipitation and surface runoff, as the water resulting from the association of hydrogen, it means that the two atoms and H2, and oxygen is by for the most abundant substance in the biosphere. The water is found on the globe in various forms, for example, gaseous form, solid form, and liquid form. The water is found in various locations, for example, like lakes, ponds, tanks, rivers, oceans, groundwater soils, surface and subsurface rocks. Living organisms as water vapor in the atmosphere, as snow and ice in the high latitudes, means the polar areas, and high altitudes means the hills and mountains areas. The water is very important substance in the biosphere because it is able to dissolve almost all substances. Secondly, we will see that it has great abilities to store heat, and next one, it takes part in the nourishment of organisms, and also it helps in the circulation of elements in the biosphere. And hence the water or hydrological cycle at global scale involves the mechanisms of evaporation of water from the oceanic water through insolation. Secondly, conversion of water into water vapor or moisture. Third, transport of atmospheric moisture over the oceans and the continents by atmospheric circulation. Fifth one, to release of atmospheric moisture in the form of precipitation. So, as over the continents and oceans, and last one, that is eventually transfer of water received at the earth's surface to the oceans, means the various routes and hydrological processes which runs from surface run of and rivers. So as done meaning of this, those are as the subsurface runoff which are occurring. So infiltrate, groundwater flow, surface runoff, evapotranspiration, and closed system. Human inputs which are being seen, those are some aspects of the hydrological cycle can be utilized by humans for a direct economic benefit. As examples, you will see that generation of electricity, hydroelectric power and stations and reservoirs. These are effectively use artificial lakes, and this will disrupt river hydrology, means the amount of water in a river. Other human activities which are seen, those are as a paving, compacting soils, and altering the nature of the vegetation, means including deforestation. The mining which has been going on of the groundwater for use in agriculture and industries. Large amount of water vapor released into the atmosphere from industrial activity. Large changes in vegetation by wildfire, logging, clearance for agriculture. So as we are studying about this, that various appliances which are being used, and so what problems which are being creating, that we have seen.